Alright, so Mr. Blair is going to do some experimenting. In my research question, which type of container heats water rapidly? And the purpose would be exactly the same thing without the question saying, so what am I trying to find out? I'm trying to find out which type of container heats water rapidly. Rapidly means quickly. So my hypothesis, let's see if my hypothesis is any good. I hypothesize that the soup can will heat the water most because the can is made of metal, which helps absorb heat, and soup is served hot. I think part of it's okay. It's given me what I think. I hypothesize that the soup can will heat water the most because, you want to give a reason why. Yeah, I've done that because the can is made of metal, which helps absorb heat. It's a pretty good explanation, I like that one. I don't know how relevant, and soup is served hot. I think that can go, we can get rid of that one, it's just been silly. All right, now, the next thing is, I want to look at, and I have these different materials. These are the sorts of ones I'm going to be using. So I've got metal, I've got plastic, I've got some with lids, some without lids. I've got some soda cans, I've got a jar, glass jar. So the independent variable, which is the one change I would make, is the container, the actual container itself. So it's made from a different material, the size of it and the shape of it. Some might have lids, some don't. So that's the one change. They're all different in some way. Dependent variable is what I will measure. And what I'm trying to measure is the temperature of 250 mils of tap water. So I want to find out which container has become the hottest after 1 hour. So I'd have to measure them both at the start, all at the start I should say, and then at the end, which one has increased the most. The constant variable or controlled variable, which is the thing you keep the same. And what I wanted to keep the same was the amount of water, which is 250 mils of tap water. It wasn't all different water, it was the same type of water. The placement of the containers, where did I put them? Were they all in the sun? Were they in the same area? Or were some sheltered from the wind and others exposed to the wind? So you want to think of, make sure it's a fair test. And I also want to make sure that I keep the same is the time allowed for heating the water. It's not fair if you give some half an hour and some 1 hour. That would be invalid. Okay, that means it wouldn't be a fair test. My procedure. These are my steps that I take. So remember, here is our lab report that would follow. The materials. Oh, I missed the materials. The materials are over here. And the materials I use for this particular one, empty containers. And for examples, I had 250 ml soda can with plastic lid, 250 ml soda can with no lid, a 500 ml bottle with lids and without, biscuit tin, which was round, no lid. I should probably also mention what material it was made from. Okay, so the water bottles wouldn't be made from metal. Biscuit tins would be from metal. Plastic container, which was thin, see-through, no lid, and glass jar with no lid. And I also needed a measuring cup to measure 250 mils, a funnel, so it'd go in, I'd not spill any drops. I need the water, thermometer to measure the temperature, and timer, so it'd be accurate how long it is. And my procedure. Okay, so we've looked, remember these ones? Research question, purpose, hypothesis, materials, variables. The I, think of one change, the one thing that you'll change. I looks like a 1. Dependent is what you measure, and the constant, those are the things that stay the same. The procedure is the steps. So if you wrote this out, someone would be able to do exactly what you did. In this procedure, fill jugs with tap water, measure the temperature of water, and record the starting temperature. So you want all the water to be the same temperature. Fill a 250 ml measuring cup with water from the jug and place in each container. Place the containers of water in direct sunlight in the same location, because we want to try and work out, can the sun heat the water, and how hot can we get it? Record the time you started along with the air temperature, because if someone did it in summertime in the UAE, your starting temperature might be at about 48 degrees. Yet when I am going to do this now, the actual air temperature is actually 24 degrees. It's quite a big difference. In fact, it's half. So it wouldn't be fair unless, it just wouldn't be fair. Remeasure your water temperature accurately after 1 hour and record your results. Okay, and then your observation, what I observed. Okay, and so you explain what you observed. Was it a fair test? Was it not? Conclusion. This is probably really when you start talking about your conclusion and being at a fair test or not. Now I noticed there could be different things. It could be the placement where I put it. There might be some animals that come along and drink the water. There might be the movement. Well, it's not the movement of the sun, is it? Or is it? Is it the earth that moves, or is it the sun? Oh, question, good question. But you'll notice that the shadows do come over, and it wouldn't be fair if half of them were covered in shadows and half were in direct sunlight. So just be aware, where you place it, it should have direct sunlight for how long your experiment is going to go for. All right, that's what we're doing. Good luck.